This is 6.01 Algebra 2 homework. So it's a little difficult here because it's a photocopied sheet. So I wanted you to be able to see the sheet, so I have it here on the left, and then I'm going to do the work off to the right. So the first one, we're trying to find each value as a fraction, and then also as a decimal, rounding to the nearest hundredth. So for 2a, we're finding the sine of angle A. So really important, at the top of your paper, you should have SOHCAHTOA written out. So I like to circle the angle I'm working with, so I'm on angle A. So sine over here is opposite over hypotenuse. So opposite angle A is 15. The hypotenuse is 17. Opposite across, 17 is across from the right angle. This asks for a decimal, so you're going to go into your calculator, type in 15 divided by 17. Rounded to the nearest hundredth, which is approximately 0.88. I'll do the first couple decimals with you just so you understand what they're asking, and then I'll let you guys do those on your own. So secant's the reciprocal of cosine. C's and S's go together. Since cosine's adjacent over hypotenuse, secant's hypotenuse over adjacent. So the hypotenuse is 17. The adjacent to angle A would be 8. 17 over 8 in your calculator should give you approximately 2.13. Letter C is the cotangent of angle A. So cotangent is the reciprocal of tangent. So instead of opposite over adjacent, it's adjacent over opposite. Adjacent is 8 over opposite, which is 15. 8 out of 15, type that in your calculator, you get approximately 0.53. Letter D is the cosecant of angle B. So now I'm going to erase my circle around A, and instead I'm going to circle angle B. There we go. So now I'm finding cosecant, still the reciprocal of sine, so that's going to be hypotenuse over opposite. So the hypotenuse stays the same, but this time the opposite from angle B is going to be 8. And then again, type in 17 divided by 8 in your calculator to get your decimal. Letter E is the secant of angle B. So that's the reciprocal of cosine. So that's going to be hypotenuse over adjacent. So 17 over 15. And then lastly, letter F for this one is the tangent of angle B, which is SOHCAHTOA. So opposite of angle B is 8, and adjacent is 15. All right, number 3. This time we need to draw our own picture. So we are given that triangle GHI is a right triangle with angle H is our right angle. And we know GH is 40. The cosine, which is adjacent over hypotenuse, is 40 over 41. Well, adjacent to angle G is 40, so that means the hypotenuse must be 41. Use Pythagorean theorem, so 40 squared plus your side G squared equals 41 squared. To calculate your missing side, subtract 40 squared from 41 squared, we get 81, so G must be 9. It's a Pythagorean triple. All right, so for letter A, we want the sine of angle G. So again, I have G circled. Sine is opposite over hypotenuse. Hypotenuse is opposite the right angle. Opposite angle G is 9, so that's 9 over 41. Letter B is the sine of angle I. So again, that's opposite over hypotenuse. Opposite angle I, I'm going to circle that in blue. Opposite angle I is 40, and the hypotenuse is still 41. And letter C, we have the cotangent of G. Cotangent's the reciprocal of tan, so tangent's opposite over adjacent, so we're doing adjacent over opposite. Adjacent to angle G would be 40, and then opposite of angle G would be 9, so 40 over 9. All right, letter D is the cosecant of G, which is the reciprocal of sine, so that's going to be hypotenuse over opposite, so that's going to be 41 over 9. Letter E is the cosine of I. Cosine's adjacent over hypotenuse. Adjacent to angle I is 9. Your hypotenuse is 41. And lastly, letter F This one's a problem because you're trying to find the secant of the right angle, and you're not allowed to find the secant of the right angle, so that's not going to be defined there. You can only find sine, cosine, tangent, or the reciprocal functions of the acute angles. All right, next up is number 4. So for number 4, we have triangle PQR with angle R as our right angle. The cotangent of angle P is the reciprocal of tangent. So tangent's opposite over adjacent. So this is adjacent over opposite. So adjacent to angle P, let's label as 5. And opposite angle P, let's label 12. Do the Pythagorean theorem. 5 squared plus 12 squared equals R squared, to find that R is 13, or if you know that that's a Pythagorean triple. All right, it says to find the values of the other 5 trig functions. So we have one of them is cotangent. We need to find sine of angle P. So sine is opposite over hypotenuse, so that's going to be 12 over 13. We have the cosine of angle P is adjacent over hypotenuse, so adjacent to P is 5, hypotenuse is still 13. Tangent of angle P is opposite over adjacent, so that's going to be 12 over 5. Reciprocal of sine is your cosecant, so we're just going to flip that so it's 13 over 12. And the reciprocal of cosine is secant. Flip that one's going to be 13 over 5, and they already gave us cotangent. All right, next we're going to do 5, 6, and 7. So we're setting up some equations here. So for number 5, I want to circle the angle that I'm using. And I'm going to label, I have my hypotenuse here and the adjacent side. So if I have an A and an H, if I write out SOHCAHTOA, ask myself which one has an A and an H, and that's cosine. So I always do cosine of the angle, so that's cosine of 55 degrees equals adjacent, which I label as 24, or my hypotenuse, which is x. Put cosine 55 over 1, cross multiply. Please, please, please make sure that your calculator is in degree mode when solving these problems. Okay, so now you're just typing 24 divided by cosine of 55 in your calculator, and then round to the nearest tenth, you should get 41.8. All right, on number 6, you're going to do the same thing. Circle your angle, which is 34. I'm going to do this one over here. I have the opposite and an adjacent side. So I look over here and I see tangent has an O and an A. Tangent of the angle equals opposite 17 over adjacent, which is x. Put it over 1 and cross multiply. Now to solve for x, divide both sides by tangent of 34. Again, make sure your calculator is in degree mode and type it in. And you should get to the nearest tenth, 25.2. And then I'll let you guys do the last one. Again, circle your angle. This one you've got opposite and hypotenuse, so you want to use sine. And for number 7, your answer should be 10.6. I'll let you guys do the work out for that one. All right, I'm going to erase this work I have, so I have more space for my next one. I'm looking at number 8, and I've got a flagpole here. The tallest flagpole in the world was in 1915, was in San Francisco. So we've got a picture drawn off to the side here. And we know that the angle of elevation, so your look-up angle, is 55 degrees. And our shadow is 210. All right, so 55 and 210 is adjacent. And we're looking in part A for the height of the flagpole. So that's going to be over here. Let's call it X. That's going to be my opposite side. So O and A. So again, you want to look at your SOHCAHTOA that you have written out. So SOHCAHTOA. We've got an O and an A, so that's tangent. So we're going to do the tangent of 55 equals opposite, which is x, over adjacent, which is 210. Cross multiply. Make sure you write the 210 first. Put that in your calculator. And you want to round to the nearest foot. So that's going to round to 300 feet. Okay, for 8b, I'm going to do over here. We want to know the length of the shadow. So it's no longer 210 feet when the angle of elevation is 34. So if this is 34 degrees, this angle, we want to find what the length of our shadow is. Well, now we know what our height of our flagpole is going to be. There's 210, 10 of 55. Okay, so let's go ahead and write this out. We've got over here is our 300 feet. So we're going to take tangent of 34 equals opposite, which is 300, over our shadow. Let's call that shadow y this time. Put it over 1, cross multiply, y times the tangent of 34 equals 300. And then do 300 divided by the tangent of 34. And if we round to the nearest foot again, we'd get approximately 445 feet. All right, and then letter C, just ask what you want to assume about the flagpole and the shadow to solve the problems. You're assuming the flagpole is straight. You're assuming the ground is completely flat, that the flagpole is forming a right angle with the ground, and so that you're assuming you can use the properties of a right triangle. All right, on the bottom, these are really just typing into your calculator. So you're going to type exactly what you see. To get these -1, you're typing second cosine of rad 2 over 2. So go ahead and type those in, and then you're going to round those to the nearest minute. So in your calculator, if you use the second apps button, which is the angle menu, you can convert them to degrees, minutes, seconds. And that's going to mean you're going to round to the nearest minute. And just remember that if you have 30 seconds or higher, then you're going to round up to the next minute. So the first one ends up just being 45.0 degrees. But if you look at number 10, you have inverse tan, so you're going to do second tan of 0.3333. And then hit second apps, go to DMS, and you'd get 18 degrees, 25 minutes, 59.628 seconds. So since we want to round to the nearest minute, we're looking at how many seconds we have. And since it's more than 30 seconds, that tells you that you want to round up. So you're going to round to 18 degrees, 26 minutes for that one. Okay, and then I'll let you do number 11 on your own. All right, and now going to the back, you have 2 more problems back there. They look a little bit different. So here we're given triangle ABC. Angle C is a right angle. Find the remaining sides and angles. Okay, so for this one, we are given that B, so lowercase b, that's opposite angle B, is 5, and lowercase c is going to be 10. So you have a couple options here where to start. One way could be to find the length of your third side. So you could use Pythagorean theorem to do that. So if we call this lowercase a, that would be 5 squared plus a squared equals 10 squared. So if we do 100 minus 25, and That gives us 75, and then take the square root of 75, and we want to round that to the nearest tenth, so that would be 8.7. So that's one side. Now we need to find our missing angle. So to find, let's say, angle A, best bet is to use the sides that you have. So I have the adjacent side. So I wouldn't use this side because it's rounded value. So I have adjacent and I have hypotenuse. So cosine is A over H. So I'm going to do cosine of angle A equals adjacent 5 over hypotenuse 10. Now, anytime you're looking for the angle, that's when you want to use that inverse cosine or the -1 or second cosine. So you're going to do second cosine in your calculator, then type in 5 over 10, and you get angle A is 60 degrees. Since this says nearest tenth, I would just put a 0 in for that placeholder. And then you want to do angle B. So you could just, at this point, subtract 60 and 90 from 180, which would give you 30 degrees for angle B. Or, oh, scared me. Angle B, you could also do opposite over hypotenuse and then do the inverse sine to find that. All right, and then on the back, there's one more you guys had to do, which was question 37. So for 37, again, we have a right triangle. Angle C is a right angle. And we're given angle A is 52, lowercase c, so that's side C is 10. We want to find all missing sides and angles. So first, I might start by just subtracting 52 and 90 from 180 to get the measure of angle B. So when I do that, I get the measure of angle B to be 38 degrees. Measure of angle B equals 38 degrees. And now I still need to find the lengths of my sides. So to do that, we could use, I want to use the 52 just because in case I miscalculated the 38. So if I want to find side B first, then I know I have my hypotenuse, which is 10, and I'm looking for the adjacent side. So let's write out our SOHCAHTOA. A and H is cosine, so I can do the cosine of 52 equals the adjacent, so let's call that lowercase b, over hypotenuse, which is 10, put it over 1, cross multiply, so I get 10 times the cosine of 52 equals b. Make sure that you are in degree mode, and then you're going to round to the nearest tenth, so that's going to be approximately 6.2. And then the last one, we want to find the opposite and use the given 10. I'd rather not use the 6.2 because that's rounded, and I could have calculated that wrong. So I'm going to take the sine of 52 equals the opposite, which we're going to call that side A, over hypotenuse, which is 10, put it over 1. 10 times the sine of 52 equals A. Type in 10 times sine of 52, make sure you're in degree mode, and round to the nearest tenth, which would be 7.9. So now we know all three sides and all three angles. All right, I hope this helps. See me with any questions.